Hello students, this is the third video of the series Chemical Reaction and Equations. In this video, we will discuss about the remaining reactions such as displacement reaction, redox reaction and rancidity. Displacement reaction. The reaction in which very more reactive element displaces less reactive element from its salt solution is known as displacement reaction. We can classify displacement reactions as single displacement and double displacement reaction. Iron is more reactive than copper. So therefore, iron easily can displace from copper sulfate solution. It can displace copper from copper sulfate solution. So this is a very good example to explain displacement reaction. This is a very simple experiment. So easily explain displacement reaction. Take copper sulfate solution in a test tube, which is blue in color. Place an iron nail in the solution. You have to leave it, the setup, for some time. After some time, we can notice that copper deposit on the iron and the color of the copper sulfate solution will change into greenish because of the following reaction. Because you know that iron is more reactive than copper, it easily displaces copper from copper sulfate solution and take the place of copper and become a iron sulfate. So this is a very good example of. So I already told you we can classify the displacement reaction as simple displacement and double displacement reaction. The single displacement reaction, one more example I want to explain. Magnesium reacts with copper sulfate. Again copper sulfate. So it will form magnesium sulfate and copper. Obviously, magnesium is more reactive than copper. So therefore, magnesium can easily displaces copper from its copper sulfate solution and become magnesium sulfate. Then double displacement reaction. Here I will explain about ions. You already know that the ionic compounds made up of ions. Calcium carbonate reacts with HCl, it becomes calcium chloride and H2CO3, that is hydrogen carbonate. So here exchange of ions you can see in the slide. You can see the exchange of ion because calcium carbonate made up of calcium and carbonate ion and HCl made up of H plus and Cl minus ion and calcium chloride. So exchange of ions can take place in this reaction. So reaction in which exchange of ions takes place, that is a double displacement reaction. So one more example I want to explain, that is lead 2 chloride reacts with potassium iodide. You can clearly see that lead ion and chloride ion, potassium ion and iodide ion. So how the exchange of ions takes place here. So that is here double displacement reaction. Then I want to explain about oxidation reaction. Oxidation, that means loss of electron, gain of oxygen and loss of hydrogen. So any one of the action you can see in a chemical reaction, that is a oxidation reaction. So a very good example is sodium can lose one electron to become sodium ion, and carbon reacts with oxygen to form carbon dioxide, and hydrogen sulfide become sulfur. So here you can see in the first case loss of electron, the second case gain of oxygen, the third case loss of hydrogen. So these all are the examples of oxidation reaction. Next is reduction reaction. So reduction reaction, you can see the opposite of oxidation reaction, gain of electron or loss of oxygen or gain of hydrogen. Any one of the action you can see in the chemical reaction, that is a reduction reaction. So I will explain with example. Here the chlorine can gain 2 electrons to become 2 chloride ion. It is a reduction reaction. And copper oxide combined with hydrogen, so it becomes copper and water. So that is here one of the example of reduction reaction. Then nitrogen reacts with hydrogen to become ammonia. So this is a gain of hydrogen. So gain of electron, loss of oxygen, and gain of hydrogen. So that is a reduction reaction. Then I will explain about redox reaction. What is redox reaction? The reaction in which both oxidation and reduction takes place simultaneously, that is a redox reaction. So in the redox reaction, if any substance gains oxygen, that is said to be oxidized. If a substance loses oxygen during the reaction, is said to be reduced. The substance gain hydrogen during the reaction, it is said to be reduced. If the substance loses hydrogen during reaction, it is said to be oxidized. And you can say about the electronic way of explanation also. A substance can lose electron, that is oxidized. The substance will gain electron, become reduced. So that is a redox reaction. So the very good example of redox reaction is CuO plus H2, it gives Cu plus H2O. Here copper oxide, it become copper. That is what? Loss of oxygen. So loss of oxygen is reduction. And oxygen, water will form from hydrogen by gaining hydrogen. So this way both oxidation and reduction can take place simultaneously, this reaction. That is why this reaction is known as redox reaction. Now I will explain about oxidizing agent and reducing agent. And what is oxidizing agent? The substances which provide oxygen or which removes hydrogen to help oxidation reaction, that is oxidizing agent. So any substance which provide oxygen for oxidation or which used to remove hydrogen for oxidation, that is oxidizing agent. And what is a reducing agent? The substance which provide hydrogen, this is opposite of oxidizing agent. The substance which provide hydrogen and removes oxygen and help the reduction reaction is known as reducing agent. So these are the definitions for oxidizing agent and reducing agent. So you can see the oxidation agent and reducing agent both in the redox reaction. And the next one is the oxidation and reduction reaction in our daily life. You can see lot of things happening around us, especially corrosion and rancidity. So these are the examples of redox reaction. You know what is corrosion? So the rusting is a very good example of corrosion, rusting of iron. But not only the rusting of iron, so corrosion is a very general thing. And what is corrosion? Suppose you want to describe what is corrosion. It is a slow process of self-oxidation. It is a slow process of self-oxidation in which a metal undergo layer by layer destruction after reaction with atmospheric oxygen and moisture. That is corrosion. So rusting of iron, tarnishing of silver, copper turns green when exposed in air. Even rusting of iron is a very good example, and tarnishing of silver also. If you keep the silver object in the open air, what will happen? That shiny silver color will change. So the black coating will appear. So that is a tarnishing of silver. So that is also a corrosion. And next is rancidity. Everyone, most of you, not everyone, love chips. So the chips packets filled with gas inside it. That gas prevents rancidity, because you know that the oily substances, oily food substances, that simultaneously they will react with air. If you keep open the oily substances, what will happen? The oil will rancid. That will react with oxygen, and the nature of the oily substance will change. So you can say that the butter turns rancid if you keep the butter. So how can you prevent rancidity? The very good example, you know that we have to keep the butter in the refrigerator. So that means you have to keep that food item in very low temperature. That is one of the example to prevent rancidity. And obviously you know that you have to keep the food item, the oily food item, in a airtight container. So that also to prevent rancidity, because we can reduce the contact of air. So you have to store the food item in the container to stop reactions by the help of sunlight. So these are the things about the rancidity. So here in this slide you can see the high order thinking skill questions. Dear students, so these questions I have prepared for you for better understanding this chapter. So please go through the questions and try to answer these questions. So this is actually a high order thinking skill questions. Thank you students for watching my third video of this chapter. See you again in the next video. Till then, bye bye. Thank you very much for those who subscribe my channel.